Hi, everyone. I hope you had a wonderful break. This is Mr. Conron from the Sky team. I'm going to talk today about dividing fractions and using tape diagrams as a wonderful representation of that division. So let me make myself a little smaller here and move off to the right. Let's start with something that you may have seen before the break, and that is 10 divided by 2.5. The tape diagram can be used to really represent 10 as a length, and that the individual boxes here are units of 1. And when we divide 10 by 2.5, there's a couple of ways we can think of that. 2.5 can be a group of 2 1/2 boxes. And we can also say, well, let's determine how many times we can take 10 and divide it into lengths of 2.5. So there's many different ways. We've also seen it again as how many 2.5s are there in 10. So just by looking at this diagram, hopefully you can see that each of these red lines represents the break between the boxes, imaginary boxes that are 2.5 units in length. And you can fit 4 of those boxes here. So a nice way to visualize 10 divided by 2.5 is using a tape diagram, and it demonstrates that 10 can be divided into 4 blocks of 2.5. I have a second example. Again, you may have seen where 7 is divided by 2. And in this case, we have groups of 2 instead of 2.5. Again, many ways of asking the question. For example, how many times can 7 be divided into lengths of 2? So if we were to count, we can see that there's one length of 2, there's a second length of 2, a third length of 2. But then what do we do when there's something left over that doesn't naturally fit into a full length of 2? You might think of taking this box of 1 and say, well, that's 1/7 left over. But what we're talking about is dividing it in this whole length into boxes, imaginary boxes with a length of 2. But this one length is half of the length of 2. So instead of saying we have 3 groups of 2 and 1/7 left over, we instead have 3 groups of 2 and 1/2 of a group of 2 left over. So that leaves us with 3 and 1/2 as our answer when you divide 7 by 2, so 3.5. So moving on to my last example, and this is a little bit more complicated, but how much is 1 divided by 2/3? Again, I like to think of 1 as my length, and I look at 3 individual boxes because we're dividing by thirds. Yes, it's a group of 2/3 that we're really dividing by, but it's a nice way of looking at it when you break it into 3 individual pieces, since really we're dividing into thirds initially. So I have a group of 2/3, and like in the previous problem, I have something that's left over to complete the length of 1. And once again, I'm looking at this box, which has a length of a third, like this blue box and this other blue box. And instead of saying that I now have a group of 2/3, and a 1/3 giving me 1 1/3, that would be incorrect. What I really have it is 1 full group of 2/3 and half of a group of 2/3. So really, I'm taking this third of a length, dividing it by 2/3 of a length, and I end up with 1/2. So my answer to what is 1 divided by 2/3 is 1.5. So if that's not entirely clear to you, it might be worth going back a little bit and maybe 2 minutes and listen to what I have to say, and hopefully that's clear. Good luck with that.